Hi, Braden Swan. Last part of this week's discussion, starting with the divergence of a vector field. Now, the divergence boils down to the dot product of the gradient times the vector field function or vector field, and that equals this partial differential string, which in the end is a scalar. Now, this scalar actually is very powerful because for a velocity vector, it is the rate of flow inward or outward at a point. So when you look at fluid flow, this is going to tell you really what's happening to the fluid as it's traveling at that point. And so if the value is positive, flow is expanding. You've got maybe gas that's under pressure, that's the pressure is being relieved or it's escaping through a valve or something. If the value is negative, it's contracting. This could be fluid compressing as it goes through maybe a piston is compressing or something. And then if the value is zero, this is what would be considered incompressible. And that's kind of for your normal everyday water flowing through a pipe, relatively moderate pressures. That's fairly true, and water flowing through a pipe is a good example of an incompressible. Now, the curl of a vector, now that is going to basically measures the rotation or the spinning effect in the function. So this basically, if a fluid particle is going to start to spin or something, this is what's going to tell you. Now, the curl is the cross product of the gradient and the vector function. You can see on the screen I've got the what that results in. But what it really tells you is the curl lines up with the axis of rotation, and then its magnitude indicates kind of how the strength of the rotation or how fast it's going to be rotating around that axis. To determine the direction, you can simply use the right-hand rule, and it's very powerful. It's kind of like if fluids, nice laminar fluids, just going to be going in the center of the pipe, won't have much curl, but you appear at the mid-tide, it's going to have the fluid wrapping around it. It's going to have this kind of rotational measurement. If you had a function for that, you could determine it. So the video is a little long. I'm going to let you go.